Hi guys, so today we're looking at the worksheet linear functions. So just as a reminder, I have the definition here for finding slope, right? So this definition. So we looked at this before, so if we want to find the slope between 2 points in the coordinate plane, then we use lowercase m for slope, right? And we can find it these different ways, right? We can represent it in this form, where the 2 points, or change in y over change in x, or rise over run, or total change in the output compared to the total change in the input, right? So slope is simply just the ratio, right, of the total change in the output to the total change in the input, right? Notice here it says that x1 can't be equal to x2, right? Because if that's true, then this bottom value here will be 0, which we can't divide by 0. So in order to calculate slope for something to have slope, we can't have both x values being the same, right? In that situation, slope is undefined, right? That's where we have a vertical line, right? All right, so here we have the following table gives the about a buddy spent on Social Security in this country. So we're given year and then Social Security outlays, right, which is how much was spent, and that's in millions of dollars, right? So this is data from Social Security. So number 1 says take the first and the last points and compute the slope. Interpret as a rate, something per something, right? So we want to interpret it as some rate form, right? All right, so to find the slope, right, we would take y2, right, so 523,305 minus y1, right, which would be 64,658, right? So I'm thinking of this is x1, y1, and this is x2, y2, right? And just plugging in that formula. So then this would be over, and then we'd have 2005 minus 1975. Right, so you can plug this in your calculator, simplify, right? So 523,305 minus 64,658. So we get 458,647, right? All over. And then 2005 minus 1975, right? I can just do that in my head. That's 30. So then if I take that value, divide by 30, right? We get so if we just round to the nearest whole number, we get a slope of 15,288. This would be over 1, right? Or simply just 15,288. Okay? So if we want to interpret this as a rate, we could say Social Security outlays have been increasing since 1975, right? Increasing because this is a positive slope, right? At a rate of 15,288, and this is in millions of dollars, right? Millions per year. Right? That's how we can interpret that sentence, right? So actually, I posted this from the page, right? Which is another way. Oops, actually, let me go back. So let me just copy this. Right, so I have this on the bottom here, but I'll paste this here as well if you'd like, right? Because we could redo this sentence using this guide that's in the book, right? So let me actually make this a little bigger. Right? So this is a really good, oh gosh, what'd I do? Right, so this is a really good sentence also to use. So this is in the book. So at the very bottom of the notes, I was going to talk about it at the end, but I guess it makes more sense now. This is on page 5-6 in the text, and I highly recommend knowing how to make this generic sentence. It's very helpful in interpreting the slope. And you want to put this on an index card for the final exam, right? That's how important it is. That's something that I would do. So you can use an index card for the final exam also. And the final exam only covers the material since the midterm, right? So it's not cumulative. So everything that was on the midterm, that stuff will not be on the final, at least directly. Right? All right, so we could make another sentence. So we could say the output. So my output here is the Social Security's outlays, right? So we could say the Social Security outlays is changing by, so my slope is 15,288, and then you got to put units, so millions of dollars, right? So I'll just do $ in the millions. Per, my X unit is year, right? So per year, right? So this is a sentence interpreting that slope, right? So you want to be able to replicate this, right? So the main part of the sentence that you want to know is this part, right? The output is changing by the slope, Y units per X units, right? So you want to make sure you can do that on your own. All right, so then number 2, so it graphed the scatter plot for us, and we're asked to draw the line between the 2 points on the following graph, right? So we're talking about the first and the last point. So let me see if I could insert a line. All right, so I'll try to draw the line the best I can. I don't have like a virtual ruler I can use. At least not one that I know about. Well, here I can use this. So I'm going to draw a line from here through the last point, which is here, right? So there's my line. And actually, let me change that. Let me use this red and then grab that. Alright, so now this will be better. Alright, so we want it to go through the first and the last point. So something like this, right? So draw your line, it'll look something like this. So now it says compute the equation of the line y equals mxb by plugging in an xy point and the slope m and solving for b, right? So I already have slope, right? I already know my slope is, so we had 15,288, right? And this was rounded, but for our sake, it's okay to use this rounded answer, right? Just so it comes out nice and neat. So now, what we need to do, right? So if I want to put it in this form, I know slope. I need to find the y-intercept, right? So I need to plug in a point and figure that out, right? So I could plug in the point. Let's see, we have the point 1975 and what was it, 64,658. Right, I could plug in this point. So by plugging in this point, I need to solve for b, right? So what we would have is 60, excuse me, this is a 4, right? 64. So 64,658 equals, and then I would have my slope, which is 15,288, times x, which is 1975, plus b, right? So I need to subtract off this value from both sides, right? So let's go ahead and find that. So we have 64,658 minus, and this would be equal to b, right, after I solve. So if I take 15,288 times 1975, right, I get that large value, right? So I need to take 64,658 minus that answer, so second answer, and we get that value for b, right? So we have to take this by this. So 301,938 and 2 zeros, right? So we get what, 30 million. So then after I subtract that off, we end up getting b is equal to negative so 30,129,142, right? So in other words, my equation is y equals my slope 15,288 x minus, and then my b value, which is 30,129,142, right? So this is the equation of this line, right? Excuse me. Right, so we had to use either the first or the last point, right? Because those are the only 2 points that we know are on the line. So then the next part, number 4, it says, where does your line look like it will hit the vertical axis on the graph? What year does this vertical axis correspond to? How does this relate to the value of b in your equation in number 3, right? So we're trying to estimate if this were to keep going down, right, keep extending, where do we think it would hit on the y-axis, right? So I estimate that it'll hit at about negative 5,000. Right, so that's where I think that'll hit. In the year that it is when it hits the y-axis is the year 1970, right? So the year is 1970. So it says, how does this relate to the value of b in your equation, right? So it's important to note that this actually is not the y-axis, not the y-axis, right? Actually, what that is the line x equals 1970, right? So the value of b corresponds to the y-intercept, which occurs 1,970 units to the left, right? So actually, the b value is where it would cross the y-axis. So basically, here is my graph. Right, so this is actually the y-axis. This is the origin, right? 0, 0. Right? But our graph starts at 1970, right? So here, let's imagine this is the line x equals 1970. That's actually this part of our graph right up here. So then I have my line, right, with my data points. So we're trying to see, well, it looks like this might hit down here at about negative 5,000, right, which is what I was guessing. But that's not actually truly the y-axis, right? So the y-intercept b is corresponding where this line hits the y-axis over here, right? Which we found to be this value, this 30 million number. So the b value is talking about where this hits the y-axis, right? So it's just important to note that that's not really the y-axis, right? That was the big thing from that question. All right. So number 5 says, now fill in the year since 1975 column in the table and put the corresponding numbers on the x-axis of the graph. Draw a vertical line through x equals 0 on the graph. This is your y-axis. Right? So if we fill these in, right, we would have what? 0, 5, 10, 15, 20, 25, 30, 32. Right? Alright, so we filled in that column. So now we want to put the corresponding values on the x-axis of the graph, right? So if I go back up here, right, let me do some erasing. Right. So I'll redraw that line. Right, so my line looks something like this. Let me fix this. Oops, did not mean to do that. Just trying to fix this line. I don't think it's going to let me. That's going to bug me, so let me redo it. Try to get it as exact as I can. Alright, so that's pretty good, right? So there's our line going through the first and the last point. And then we were just asked to come down and fill in my new x values, right? So this would be 0, 5, right, 10, 15, 20, 25, 30. And then we had 2012, which would be 32, right, over here. So that corresponds to 2012, right? So we filled those in. And it asks us to draw a vertical line through 0. So that would be here, right? So now this is my y-axis, right? So we just moved my x values to be, for 1975 to be x value of 0, right? So now it asks us to compute the equation of the line through these points now, right? So first we need to find the slope, right? So we would have 523, 305 minus 64,658 all over 30 minus 0, right? So this slope comes out to be the same still, right? 15,288, right? If we round again. So I get an equation y equals 15,288 x plus b, right? And I can plug in one of these points to find b, but actually this point is in the form 0b, right? So this number is b, right? So you can plug in one of these points and figure it out, or you can just notice, oh, that's b. So my equation then is the following. Right? So y equals 15,288 plus 64,658, right? So we're asked what's different now. So what's different is the slope is the same, but we have a new y-intercept, right? So that's important to note, right? So the same slope by doing this, but we have different y-intercept, right? So sometimes it's helpful to, when we're looking at data like this, to like rescale your x values, right? So instead of letting x be 0 years, we could make x be the number of years after 1975, like in this example. And it just makes it a lot easier to work with, right? So the number 7 says, now consider the trend line, best fit, or least square line in the following graph. How does this line differ from the one you drew, right? So one thing that we're going to look at in this section is how to do some linear regression, or best fit line, trend line, or least squares line, right? Those all have the same meaning. So what we're looking for is what line is the best fit of our data, right? So it's really hard to do that by hand, so we're going to use Excel to find that for us. But what Excel is trying to do is minimize the distance between the point and the line, right? So we're trying to minimize those distances, right? So the question says, what's different? So if we compare this graph to the other graph, it looks like the best fit line is below ours, right? So best fit looks to be like the best fit is below ours, and has a slightly smaller slope, right? That's what I would conclude. So let me draw this really quick so you can see. Right, so we went the first and the last point. So my R line looks something like that, right? So you can see how the least fit squares line is below ours, and it seems to have a slightly smaller slope, right? It's not as steep. It looks to be a little smaller, right? So this is the output that you can get in Excel. So this top part is the equation of this line, and this r squared value, what this does is it gives us a means of knowing how well our line fits our data. So the r squared value actually tells us what percentage of what percentage that our graph is explained by the model, right? So the variation explained in the model. So I won't get into r squared values, but just note that values close to 1 are good, and values close to 0 are bad, right? So the closer this is to 1, so r squared will always be in between 0 and 1, and closer to 1, close to 1 is good. Right? So that tells me that my line of best fit and my points are close together, right? So like this is a really good fit, right? 0.98, right? Can't get much better than that, right? So we won't go into a lot of detail, but that's enough for you to know right now. Right? So now it says use both your line, x equals years since 1975, and the best fit line to predict Social Security outlays in 2012. Which is closer to the actual amount of 808.04 billion, right? So we want to try with both. So if you do this with the equation y equals 15,288 times 37, right? So there's 37 years past 1975, right? 2012, right? So then we need to add in the 64,658. Right, and in doing this, right, so take 15,288 times 37 plus 64, 658. Right, so I get 630, 314, right? So 630, 314. So this is the actually the amount that I get with this line, right? So this is hours, and then we can look at the best fit line and see what that gives me. So this would be 15,035 was the slope plus 44,344, right? So again, I'm pulling this off of here, right? This tells you the equation of the line, right? So if we simplify this, you should get 600,639. I believe is what we got before. So that's which one is closer. Well, actually, ours is closer, right? And you might wonder why. And this is because the outlays are starting to move up in a nonlinear fashion, right? So after it goes in a line, right, it starts kind of moving in a non-linear fashion, right? How it kind of has more of a curve, starting to get a curve in here, right? Starting to like curve up, right? So that's why ours is a closer fit, because ours is above that. Right. All right, so that's the end of this worksheet, right? So if you have questions, make sure you get in contact with me.